Guys, in this video, I'll be working through a 2026 grade 11 math investigation. So this was an investigation that was written by one of the schools recently, so last week sometime, and this investigation was based on trigonometry. So here is question 1. 1.1 says function values of 90 minus theta. So it says in the figure, p is the square root of 3 and 1. So notice that they have given you the coordinates of point P. And P with the apostrophe, we can call it, I'm not going to call it P prime, okay? That comes from grade 12. But let's just call it P apostrophe. It's actually the image of P, so you can call it that as well. Lie on the circle with the radius 2 units. OP makes an angle of theta, which is 30 degrees, with the axis. Now, the first thing I always suggest to my learners is that if you have a diagram given, and as you're reading the information, you notice that there are values given to you in the information that is not on the diagram, then please fill it in. So let's start off by filling in the coordinates of point P. So here we've got point P as square root 3 and positive 1. Now, you guys, without going any further, I want to make sense of this. If we analyze what we have on this diagram, we have got this triangle where the radius is 2, so R is 2, and we've got this point P where we are given the set of coordinates for P. You guys must realize that coordinates are always in the format x and y. Now, what exactly does that tell us? The x coordinate represents the horizontal distance on the triangle. So this horizontal distance is going to be square root 3, and the y coordinate represents the vertical distance on the triangle. The next bit of information we have is this point image of P. And here is a triangle formed for the image of P. Now, in this triangle, you guys will notice that the radius is 2. So how do we identify the radius? It is always the side that is opposite the 90 degrees. Here is the 90 degrees. And we are not given coordinates for P, but for the image of P. But what you guys should realize is that this original triangle, the blue triangle, is basically flipped over. So it's reflected in some way to give us this red triangle. So what you guys will notice is that where we had this vertical distance of 1, on the other triangle, it is now a horizontal distance. And where we had this horizontal distance of square root 3, on the other triangle, it is now a vertical distance. And you guys, based on this information, we can actually use this to get the coordinates of the image of P, where the horizontal distance represents the x coordinate and the vertical distance represents the y coordinate. So notice how that blue triangle is just reflected and we get the red triangle. Also, to sort out the information, here we see that x is 1 and y is square root 3 for the image of P. The next thing I want to talk about is the angles that we notice here. In both triangles, we've got this angle which is theta. Okay, so the angle is theta, and then there is another angle given to us, which is this, 90 minus theta. And notice that 90 minus theta represents this portion, which makes sense, right? Because if this is theta and a quadrant is 90 degrees, let me just show you here. If that is theta and a quadrant is 90 degrees, this angle should be 90 minus theta, which is exactly what we have going on here. Now that we have made sense of the information that we have on the diagram, let us look at the questions. 1.1.1 says, if P and the image of P are symmetrical about the line y is equal to x, write down the coordinates of the image of P. Now we have already made sense of the diagram. So we noticed that the coordinates for the image of P is 1 and square root 3. Basically, the coordinates of P were swapped around to get the image of P. So let's write down those coordinates. Image of P is 1 and square root 3. Let's go on to 1.1.2. It says use the coordinates of the image of P to determine the values of. Notice how they ask you for sine, cos, and tan for 90 minus theta. Before I answer this, I just want to remind you guys about these trig ratios and what you learned about them last year. So here's what you guys had learned last year regarding sine, cos, and tan in terms of x, y, and r. You guys learned that sine is y over r, cos is x over r, and tan is y over x. So we're going to use this to answer the questions in 1.1.2. The first one they ask us is what sine of 90 minus theta is. And they ask you to use the coordinates of the image of P. That means that we are specifically going to refer to the triangle that is red, the red triangle. But the problem is, the angle that we have in the triangle is theta, and it is not 90 minus theta. However, we can get 90 minus theta, which is going to be this portion. That is 90 minus theta. And how we know that is because if we add all the angles in a triangle, it should give you 180 degrees. If we take 180 minus 90 minus theta, we will be left with this angle, which is 90 minus theta. Meaning that to get the answers for A, B, and C, this is the angle that we are reading the values of from. Okay, so from this angle. Now the first one that they ask you for is sine of 90 minus theta. So you guys, sine is y over r. And in terms of this triangle, y is square root 3 and r is 2. So we know that value is going to be square root 3 over 2. Another way of doing this is saying that sine is opposite over hypotenuse. So in terms of this point, here is opposite, which is square root 3, and hypotenuse is r. So the answer for A is going to be square root 3 over 2. Next, we need cos of 90 minus theta. So cos is x over r. And in terms of the image of P, x is 1 and r is 2. So our answer is going to be 1 over 2. Alternatively, you can use adjacent over hypotenuse. So in terms of this angle, adjacent is 1, hypotenuse is 2. So the answer is going to be 1 over 2. And now we need tan of 90 minus theta. So tan is going to be y over x. So in terms of the image of P, y is square root 3 and x is 1. Square root 3 over 1 is just square root 3. Alternatively, you guys, you can use opposite over adjacent. So in terms of this angle, square root 3 is opposite and adjacent is 1, which gives you the same answer. So 1.1.3 says, from your results in 1.1.1 and 1.1.2 above, determine a relationship between function values of 90 minus theta and theta. So we need function values of these. Basically, we are trying to find a relationship between 90 minus theta and theta. And there's something important I want you guys to notice. That our answer of square root 3 over 2, if we look at the triangle, we can also get square root 3 over 2 without working with 90 minus theta. We can get it if we work with theta itself. In terms of theta, 1 would now be opposite, square root 3 would be adjacent, and r is still the hypotenuse. So we can get square root 3 over 2 if we work with adjacent over hypotenuse. And adjacent over hypotenuse is cos. So what we realize here is that sine of 90 minus theta is equal to cos theta. Next, we need to know what cos 90 minus theta is going to equal to. So based on our answer, we had a half. But if we work with theta instead, we can still get a half if in terms of theta we use opposite over hypotenuse. And opposite over hypotenuse is sine. So we know that cos of 90 minus theta is equal to sine theta. Now, you guys would know, if you have already started the section, you would know that this is true. Sine 90 minus theta is equal to cos theta, and cos 90 minus theta is equal to sine theta. Those actually come from our reduction formula. So that is something that is part of your syllabus for trig this year. So you can expect to learn that. We're now moving on to 1.2, and these are function values of 180 minus theta. So it says in the figure, point P is square root 3 and 1, and the image of P lies on the circle with the radius of 2 units. OP makes an angle of theta is equal to 30 degrees with the axis. So let's just go ahead and fill in those values that are given. The values are actually the same as before, where coordinates of P is square root 3 and 1. And this, let's create a triangle. This is going to be the triangle. Okay, so here's our 90 degrees. And if I fill in these values, I notice that my radius is 2. Remember, coordinates of P, X, and Y. Square root 3 will be the horizontal distance and 1 would be the vertical distance. And we've got this angle theta. For the triangle on the left hand side, we have the image of P. And I just want to start off by creating a triangle out of this. So this is what we have. Here's the 90 degrees. Here we've got R as 2. And let us try to figure out on our own what the coordinates of P, the image of P, would be. So we know that we're going to have an X coordinate and a Y coordinate. And what I need you guys to notice here is that the red triangle and the blue triangle are the same. They are the same in the sense that we have taken the blue triangle and we have flipped it over the y-axis to get the red triangle. Basically, we have reflected the blue triangle about the y-axis. And what happens when you reflect points over the y-axis? The coordinates of x changes sign. So the x coordinate of the image of P would be negative square root 3. And the y coordinate would be the same. It would be 1. Why it's going to be 1 is because the image of P and the point P are vertically in line with each other. Now that we know what the coordinates are for the image of P, that tells us that the horizontal part of this triangle is negative square root 3 and the vertical part is positive 1. We also notice that the angle within this triangle is theta, and the angle from the positive x-axis all the way to that hypotenuse here is 180 minus theta. So that 180 minus theta is extremely important. 1.2.1 says if P and the image of P are symmetrical about the line y is equal to 0, write down the coordinates of the image of P. So we have already discussed this and we've already got it. Coordinates of P image is going to be negative square root 3 and 1. And remember, you guys, this is a bit of functions application with reflections. When we are reflecting coordinates over the x-axis, y becomes negative. When we are reflecting coordinates over the y-axis, x becomes negative, like what we had in this case. 1.2.2 says use the coordinates of the image of P to determine the values of. Now we need sine of 180 minus theta. Since 180 minus theta gets us to the red triangle, that is what we're going to use. And applying what we know from before, here we have it. So sine of 180 minus theta is going to be y over r. And in terms of this red triangle, y is 1 and r is 2. So sine of 180 minus theta is going to be 1 over 2. Cos of 180 minus theta, that is going to be x over r. X is negative square root 3, r is 2. Tan of 180 minus theta, that is y over x, so it's going to be 1 over negative square root 3. So 1 over negative square root 3. 1.2.3 says, from your results in 1.1.1 and 1.1.2 above, determine a relationship between function values of 180 minus theta and theta. Basically, they are asking you, how can you use theta to get the same values for sine of 180 minus theta and cos of 180 minus theta? Now first, let's do this by referring to sine of 180 minus theta. We saw that the answer was a half. So we need to go back to our triangle and see, how can we use theta to get a half? Okay, how can we use theta to get a half? Now, in terms of theta, we would have opposite over hypotenuse. However, you guys, opposite over hypotenuse, we are no longer working with 180 minus theta. Remember, we're working with theta itself. So in terms of theta, to get 1 over a half, opposite over hypotenuse is sine theta. So what does this tell us? It tells us that sine of 180 minus theta is equal to sine theta, because sine theta also gives us this value of 1 over 2. Next, we need cos of 180 minus theta, and if we look at the value, it was negative square root 3 over 2. So let's see how we can get this. Also, before I go on to this, I just want to point out that to get sine theta, we could also work with the triangle on the right. And I feel that working with the blue triangle for theta is more appropriate because remember, in math, angles are measured anti-clockwise. So to do the next one, we want to get cos of 180 minus theta. So cos of 180 minus theta, in terms of theta here, cos square root 3 over 2. However, if you work with the blue triangle, you would notice that we don't get negative square root 3 over 2, but we get positive square root 3 over positive 2. So we get cos theta, but to make it a negative square root 3, we're going to say negative cos theta. So cos of 180 minus theta is equal to negative cos theta. Okay, let us go on to 1.3. It says in the figure, point P is square root 3 and 1. Let us fill in those values. Square root 3 and 1. Remember, square root 3 is x and 1 is y. We also notice here that the hypotenuse is 2, so this is the triangle that we're working with. Horizontal distance will be square root 3. Vertical distance will be 1. Okay, and it says that the image of P lies on the circle with radius 2. OP makes an angle of theta is equal to 30 degrees with the x-axis. Now again, image of P means that this point P has been reflected in some way. So the positive x-axis to the line, the angle we have is 90 plus theta. So if we're measuring, and remember in maths, angles are always measured anti-clockwise from the positive x-axis. So from your positive x-axis anti-clockwise to that hypotenuse, the angle is 90 plus theta. Okay, now you guys, let us try to figure out what the coordinates of P image is. Since the red triangle is the blue triangle flipped over, The first thing I want you guys to notice is that this distance, which is a vertical distance, has now become a horizontal distance on that triangle. So where the distance was 1, it's also going to be 1. However, it is going to be a negative 1. How we know that it's going to be negative 1 is because if this is a horizontal distance, but it is on the negative x-axis, it should be a negative value, right? And then, this horizontal distance, which was square root 3, now becomes a vertical distance on the triangle. Which means that square root 3 is now going to be the vertical distance, square root 3. And it's going to be a positive because we are on the positive y-axis. So if the coordinates are in the format x and y, the x coordinate will be negative 1 and the y coordinate will be positive 3. And I notice an error on this question. Please take note that this is in the wrong place. The 2 is given in the wrong place. They mentioned that the 2 is the radius. Radius is always opposite the 90 degrees. So the 2 should actually be here. That is the radius. So that is kind of unfortunate for the learners who had to write this, having the value in the wrong place. So I hope that, well, hopefully their teacher would have corrected that. Okay, so seeing that this is in the wrong place, what I'm going to do is possibly just go over it to sort of mask it or erase it. Okay. So you guys can clearly see that the 2 was in the wrong place because hypotenuse is always opposite the 90. Now that we have that sorted out, let us look at the questions. 1.3.1 says, if P is rotated through 90 degrees to get to the point P image, write down the coordinates of P image. So we have already established what this is going to be. We said that the x coordinate is negative 1 and the y coordinate is square root 3. Then 1.3.2 says, use the coordinates of the image of P to determine values of. Again, you guys, we're going to use the same ratios from before. So here we have it. There's our ratios. And the first thing we need is sine of 90 plus theta. Since 90 plus theta gets us to the red triangle, that is what we're using. And also because they mentioned use the image of P. So for sine of 90 plus theta, we are using y over r. So y is square root 3 and r is 2. Cos of 90 plus theta, which is x over r. X is negative 1 and r is 2. So negative a half. Tan of 90 plus theta, that is going to be y over x, which is square root 3 over negative 1. Square root 3 over negative 1 is just negative square root 3. But if you guys want to write it as a fraction, that is fine. It would be that. 1.3.3 says, from your results in 1.1.1 and 1.1.2 above, determine a relationship between the functions of 90 plus theta and theta. Now, you guys, since they mention that we need the relationship between theta, theta lies in the blue triangle. So that is what we're going to use. The first thing we want is something from the blue triangle that is equal to sine of 90 plus theta. Now here is the value, square root 3 over 2. So we want to refer to the blue triangle and see what gives us square root 3 over 2. And in terms of theta, that is going to be adjacent over hypotenuse. And what does adjacent over hypotenuse equal to? It should be cos theta. So sine of 90 plus theta is equal to cos theta because they both give us the fraction square root 3 over 2. Next, we want to get cos of 90 plus theta. Now, if we refer above, 90 plus theta was equal to negative a half. So we're going to work with that blue triangle and see how can we get negative a half. In terms of theta, we can get a half if we use opposite over hypotenuse. Opposite over hypotenuse is sine. but we needed to get negative a half. This gives us positive a half, which means that it is equal to negative sine theta, where sine theta is a half and it multiplies by the negative to give us negative a half. So if you guys are familiar with this section of trig, you would have already realized that question 1.1 up to 1.3 has been testing you on reduction formula. Okay, we are now ready to go on to the next question. It's quite a bit of information given. Let's read. It says, we can also have angles that are larger than 360 degrees. The angle completes a revolution of 360 degrees and then continues to give an angle of theta. From working with functions, we know that the graph of y is equal to sine theta has a period of 360 degrees. Therefore, one complete wave of a sine graph is the same as one complete revolution for sine theta in the Cartesian plane. Now, you guys know this. You have covered trig functions last year, so you are aware that a sine graph is a wave. And if you do physics, you'd know it looks pretty much like a transverse wave. It is a transverse wave, and the period of this wave is 360 degrees. So 360 degrees gets us one complete wave. But what they are saying is that in maths, it is possible for us to have angles bigger than 360. And what happens if this graph were to continue beyond 360 degrees? That would mean that the wave would just continue. It would now create a new wave. So it would continue in that manner. This would be the next 360 degrees. That is all that they are saying. Okay. Here we have the basic sine graph drawn, and to the right of that, they are basically showing you if we have to separate this graph into three segments, where is each point on the graph in each segment. We're starting off at 0, we go to 90, then 180, 270, and 360. And what they're saying here is what sine is in each quadrant, meaning whether sine is positive or negative in each quadrant. In the first quadrant, we have all positive y values for sine, basically saying that in the first quadrant, sine would be positive. In the second quadrant, there's also positive y values, so sine is positive as well. But you guys notice in the third and the fourth quadrant, those y values are negative. This gives you crucial information regarding your reduction formula. It says, we can also have multiple revolution. A complete sine or cosine graph is completed in 360 degrees. This is what I was talking about, where I said that we may have more than one wave, so it goes beyond 360 degrees. And in this case, the solid line represents y is equal to cos theta, and the dashed line represents y is equal to sine theta. Now, let us have a look at the next question. So here is question 2. And 2.1 says, function values of 360 plus theta. So we want to know if it goes beyond 360 degrees, what would these be? So they say complete the following reduction formula. Now, you guys, since they are asking you for reduction formula, it would help if we have the class diagram drawn up with reduction formula on it. So let me actually do that for you guys. It would help give you a bit of insight regarding how to work with this. So you guys, here is your reduction formula, and this is what we're going to use to answer 2.1. Now, firstly, what is reduction formula and why is it important? Reduction formula allows you to reduce angles that are bigger than 90 degrees and make them less than 90. So in maths, we try to reduce angles so that they are simple. And by simple, I mean that we need them to be acute angles. Acute angles meaning less than 90 degrees. So in 2.1, we are specifically looking at 180 plus theta. But to understand this, And to understand how this works, we need to understand what the letters CAST stand for. That tells you which trig ratio is positive in which quadrant. Now, in the first quadrant, and I think let's actually label our quadrants. Much better. So in the first quadrant, the A tells you that all trig ratios are positive, meaning that if you have an angle between 0 and 90 degrees, any trig ratio with that angle would give you a positive value. In the second quadrant, S stands for sine. Only sine of an angle between 90 and 180 would give you a positive answer. Cos and tan would be negative. In the third quadrant, T stands for tan. That tells you that if you have an angle from the third quadrant, only tan of that angle would be positive. Sine and cos would be negative. C in the fourth quadrant stands for cos. Only cos of an angle in the fourth quadrant would be positive. Sine and tan would be negative. Now, to focus on 2.1, we are specifically working with 360 plus theta. And what you guys notice is that we've got A in the first quadrant, meaning that all trig ratios are positive in the first quadrant. So where we have question 2.1, sine of 360 plus theta would be positive sine theta. Cos of 360 plus theta, positive cos theta, and tan of 360 plus theta, positive tan theta. So they asked us to complete the reduction formula, so we used our cast diagram with the reduction formula on it. Now 2.2 says function values in quadrants. And to simplify expressions using reduction formula, we determine the quadrant and we determine the sign of the function value and reduce. They have given us an example. So let's go through this example to understand what they've done. And you guys, for a question like this is a typical exam style question. So once you start practicing through past paper questions, you'll notice that you have a lot of questions like this where you need to simplify. If you are struggling with these questions, I have covered quite a few of them, so please make sure that you check out those videos. Now, the first part we have is tan of 180 plus theta. And notice how in the solution, they start off by identifying which quadrant it's in. That is what you need to do. You're going to ask yourself, 180 plus theta lies in which quadrant? And according to our reduction formula, it lies in the third quadrant. Okay? In the third quadrant, tan is positive. That means that it becomes positive tan theta. Let's look at the next part. Sine of 360 minus, notice how they identify it as being in the fourth quadrant, which it actually is. Here's 360 minus, and in the fourth quadrant, only cos is positive, meaning that it becomes negative sine theta. In the denominator, we have tan of 360 minus. Again, 360 minus is in the fourth quadrant, where tan is negative, so it becomes negative tan. And from here, we're going to simplify. Tan theta over tan theta would cancel out. We've got negative sine theta over negative 1, which would give you positive sine theta. So all we are doing in a question like this is we are identifying which quadrant the trig ratio lies in, and afterwards we are identifying if that particular trig ratio is positive or negative according to that reduction formula. Now they give us another example, and in this example we're trying to see how to simplify angles that are greater than 360. So generally, if we have an angle greater than 360, we can split it up as 360 plus another angle. Or another way of understanding this is to subtract 360 from it. Okay. So moving on to the next question, we've got 2.2.1. It says, from what you have discovered, determine which trigonometric functions are positive after reduction. In the first quadrant, you guys, in the first quadrant we had A, which meant all. So all trig ratios are positive. That is going to be sine, cos, and tan. In the second quadrant, only sine is positive. Third quadrant, only tan is positive. And fourth quadrant, only cos is positive. Now 2.2.2 says use reduction formula to simplify the following expressions to a single trig ratio of theta. Now I doubt the space is going to be enough for me, so I'm going to rewrite this question and then have a look at it. So there we have it, and for convenience I've included the cast diagram with the reduction formula on the side. Okay, you guys, so remember for this kind of question we work part by part. The first part we have is cos of 180 minus theta. We're going to ask ourselves, in what quadrant does that lie? 180 minus theta lies in the second quadrant. The next question you're going to ask yourself is cos positive or negative in that quadrant? In the second quadrant, only sine is positive. So that reduces to negative cos theta. Next, we have sine of 360 minus theta. 360 minus is in the fourth quadrant where only cos is positive, so that reduces to negative sine theta. In the denominator, we've got sine of 180 minus theta. 180 minus theta is in the second quadrant where sine is positive, so that becomes positive sine theta. And we've got cos of 360 plus theta. 360 plus is in the fourth quadrant. Actually, sorry, this is 360 plus, which is in the first quadrant. So all our trig ratios are positive in the first quadrant. That becomes positive cos theta. At this point, we are allowed to cross cancel, so we notice that we've got cos theta in the numerator and denominator, sine theta in the numerator and denominator. All that we are left with is negative times a negative, which is going to be a positive, and our answer is positive 1. So notice how I answered this. I looked at the quadrant in which it lies, I checked if it's positive or negative, and then I reduced accordingly. Here is the next question. We've got B, and let's just start off by rewriting this because the space given for the answer is not enough. Or actually, it might just be. There seems to be enough lines. Okay, so working with this, we've got 360 minus. And referring to the reduction formula, 360 minus lies in the fourth quadrant where sine is negative. So that first part in the numerator is going to be negative sine theta. Next, we have sine of 90 minus theta. 90 minus theta lies in the first quadrant where all the trig ratios are positive. However, we have learnt that 90 minus theta changes sine into cos. So that is going to become cos theta. In the denominator, we've got cos of 90 plus theta. 90 plus theta is in the second quadrant where cos is negative. However, the 90 changes cos into sine. So that becomes negative sine theta. And the next one we have is cos of 360 minus theta. 360 minus lies in the fourth quadrant where cos is positive. So that becomes positive cos theta. Now you guys will notice that the negative sine thetas cancel out, cos theta cancels out. Our final answer is 1. Here is the next question, and this is for 7 marks. Again, we've got to work with the reduction formula, so let's do this. The first part we have is sine of 180 minus theta. According to our cast diagram with the reduction formula, 180 minus theta lies in the second quadrant where sine is positive. So that is going to become positive sine theta. Next to that, we've got a minus 2. And the next part I'm focusing on is cos of 90 minus theta. Remember, 90 minus theta is in the first quadrant where all trig ratios are positive, but 90 changes cos into sine. So that will become sine theta. Next to that, that is just being multiplied by cos theta. There is no reduction formula here, so we're going to keep it as is. Let's have a look at the denominator. We've got a 2, and then we have cos squared 360 plus theta. Now, 360 plus is in the first quadrant where all trig ratios are positive. So that is going to be cos squared theta. The square tells you that whatever you get, you're going to square it. And then we've got negative cos of negative theta. This is a negative angle. This is important for you guys to remember. Cos of negative theta is just positive cos theta. However, there is already a minus in front, so we're going to keep that minus and just write down cos theta next to that. Now here's the thing. You guys cannot start cancelling out and say, hey, we've got cos theta at the top, cos at the bottom, let's cancel them out. The reason why we're not allowed to do that is because we have more than one term in our numerator and our denominator, meaning that if we want to cancel anything out, we have to factorize. Looking at the numerator, we notice that both terms contain sine. Let's pull out sine theta as a common factor. In the first term, I'm left with 1, and in the second term, I've got negative 2 cos theta. In the denominator, I notice that both terms contain cos theta. Let's take that out as a common factor. And in the first term, I'm left with 2 cos theta, and in the second term, minus 1. Now, we were hoping that these brackets would be the same so that they can cancel out with each other. And we can actually get them to be the same. We notice that they do have 1 and 2 cos theta, but the signs are the opposite. So I'm going to start off by swapping those two terms around so that I have the cos first and then the 1. And the next thing I'm going to do is pull out this negative as a common factor. So I'm going to say negative, and what that does to that bracket is it gives us 2 cos theta minus 1. Now we notice that the brackets are exactly the same, meaning that they can cancel out with each other. And you guys have learned that sine theta over cos theta is equal to tan theta, which means that negative tan theta here is our final answer. Here is the last page of this investigation. We have tan of 720 degrees plus theta. Now please remember that if you have any angle bigger than 360, you are allowed to subtract 360 from it. So if we take 720 and we subtract 360, we get 360. But our aim is to keep subtracting 360 until we get an angle that is smaller than 360. And since this is an investigation, we need to show exactly how we're doing this. So I'm going to start off by breaking up the 720 as 360 plus 360 plus theta. Okay, that's what I've done. And the next thing I'm going to do is group this 360 plus theta as one angle together. Now what I have is tan of 360 plus an angle. And according to our reduction formula, 360 plus an angle is in the first quadrant where tan is positive. So what does this reduce to? It reduces to tan of 360 plus theta. And again, 360 plus theta is in the first quadrant where tan is positive, meaning that that is equal to tan theta. Let's look at the next one. We've got cos of 810 minus theta. Since that angle is bigger than 360, let's start off by splitting it up in terms of 360. So that is going to give us 360 plus 450 minus theta. And we are going to group the 450 minus theta as one angle. And according to what we know, 360 plus theta is in the first quadrant where cos is positive. So this becomes cos of 450 minus theta. However, again we notice that 450 is bigger than 360. So I'm going to rewrite this as cos of 360 plus, and that's going to be plus 90 minus theta. So notice what we do. Every time an angle is bigger than 360, we split it up in terms of 360, and we apply the reduction formula of 360 plus. Again, 360 plus is in the first quadrant where cos is positive. This now becomes cos of 90 minus theta. 90 minus theta is in the first quadrant. However, 90 changes cos into sine, and all the trig ratios are positive. So that is equal to sine theta. Next, we have tan of negative theta, and this just comes from your negative angle. So here are notes on your negative angles, which is important for you guys to take note of. Sine of a negative angle becomes minus sine. Cos of a negative angle stays as a positive, and tan of a negative angle is negative tan. So the answer here is going to be negative tan theta. And that gets us to the end of this investigation. This was for a total of 50 marks.